Hello engineers, welcome back to the Mechanical Training World channel. This is the third lecture in our series on openings and reinforcement from the ASME BPVC Code. In our previous lecture, we explored UG-36B, which covers the size of the openings. Today, we will dive into UG-36C, that is focusing on strength and design of finished openings, guys. If you haven't watched the first two videos, I highly recommend you that first watch the two videos to understand the today's topic. So let's get started, guys. So the very first one is UG-36, that is strength and design of finished openings. If you open the code, we will see UG-36C1, that is all references to dimensions in this and succeeding paragraphs apply to the finished construction after deduction has been made for material added as corrosion allowances. For design purposes, no metal added as corrosion allowances may be considered as reinforcement. What does it mean? What does it mean, guys? The meaning of this sentence is if you are calculating the reinforcement dimensions, why we need to add reinforcement first of all? Let's see. So this is your shell and this is your opening. If you are providing some openings means you are removing some extra material, right? You are removing the material. So due to this, strength of the shell decreases. So that's why we are adding this reinforcement pad. How much thickness or how much surface area is required for this reinforcement pad? You need to calculate, right? So if you are calculating that reinforcement dimensions, you cannot count this corrosion thicknesses. So you cannot count these corrosion allowances as a part of reinforcement, guys. Only the base metal is considered because which is structurally effective. Okay, because corrosion over the time, the corrosion thickness will gone, right? So that's why we are not considering the corrosion thickness in the calculations. So I hope you got this point, guys. So we'll go to next point. UG-36C3. So the code says that small openings refer to the nozzle openings in vessel that do not require reinforcement. If you follow some conditions, you will not require reinforcement pads at that opening areas, guys. So let's see what are that conditions. So the very first one is vessel thickness. So if your vessel thickness is less than 10 mm, and your reinforcement opening ID is less than 89 mm, this is your vessel thickness that is less than 10 mm and your opening ID is less than 89 mm, there is no need of reinforcement. So we will not require reinforcement pad here if you follow this condition. And what is the next condition means? If your vessel thickness is greater than 10 mm and your opening ID is less than 60 mm, less than or equal to 60 mm, then there is no requirement of reinforcement pad. So if you follow these two conditions, there is no requirement of using reinforcement pad, guys, at the opening areas. So I hope you got these two conditions in UG-36C3. So while explaining, please open the code book, guys, then you will understand much more better. So let's go to the next one. So till now we seen reinforcement required or not. If you follow before conditions, there is no reinforcement pad is required, right? So what is the minimum distance between these unreinforced openings? So if you open the code book, the code given the one formula. So to calculate minimum distance between two unreinforced openings, that is S is equal to 1 plus 1.5 into cos theta into d1 plus d2, where S is the minimum distance between two openings, d1 is the diameter of opening 1, and d2 is the diameter of opening 2, and theta is the, so listen carefully, theta is the, so this is the longitudinal plane, guys, and this is the axis of two openings. This is the axis which is connecting two opening center lines. So the angle between these two lines is nothing but your theta. The angle between the two lines is nothing but your theta. So this is the angle between center line of two openings and the longitudinal plane. I hope you got the point. So let's see with examples. So what is the minimum distance between in this condition? Here your longitudinal plane and the center axis of two openings is in same, right? Same axis or same line. So then your theta is equal to 0, right? So let's apply theta is equal to 0 in the formula. So then cos 0 is equal to 1. If you apply the same thing, so you will get S is equal to 1 plus 1.5 into d1 plus d2. So finally you got 2.5 into d1 plus d2. So this is the minimum distance between your two unreinforced openings if your theta is equal to 0. So let's see with another examples. So what is the theta in these conditions, guys? This is the longitudinal plane and this is the axis of your two openings. If you see here, theta is 90 degrees here. Okay, so let's apply this 90 degrees in the formula. So S is equal to 1 plus 1.5 into cos theta. So in cos theta place, we apply cos theta is equal to 90 degrees. Then cos 90 is equal to 0. So if you apply the same thing, you will get S is equal to d1 plus d2. Okay, so this is the minimum distance between two unreinforced openings when theta is equal to 90 degrees, guys. I hope you got these two examples. So next one is, if you find like these openings, you need to first calculate theta, then substitute in this formula, you will get minimum distance between two unreinforcement openings. Let's go to next point. For formed head, so what is the minimum distance between two unreinforced openings in formed head, guys? What is the minimum distance between two unreinforced openings in this formed head? So the code given the formulas for this, that is equal to S is equal to 2.5 into D1 plus D2. So this is the formula you need to apply for formed heads if you want to calculate minimum distance between two unreinforced openings. So this is all about UG-36C, guys. That is strength and design of finished openings. In next lecture, we will go to UG-37. Okay. So if you find this video helpful, please hit the like button and subscribe the channel. Thank you, guys.